Ever wondered if time travel is possible? We've all been captivated by the idea, haven't we? Time travel, the concept of moving between different points in time, has been a staple of science fiction for years. We see it in literature, in films, in television series, and even in video games. It has sparked our collective imagination, leading us to dream of visiting the past, glimpsing the future, and experiencing times and places far beyond our own. Many of us, though, carry some common misconceptions about time travel. We often view it as a fantastical, outlandish concept, more at home in a science fiction novel than in the real world. We imagine complex machines, intricate dials and buttons, and dramatic flashes of light accompanying our journey through time. But the reality, at least theoretically, might be far different than what we've come to expect. So, is time travel just a figment of our collective imagination, or is there more to it? Could it be a real, tangible possibility? The short answer is yes, at least according to some of the brightest minds in the field of physics. The long answer, however, is a bit more complicated. You see, time travel isn't just a question of technology, of building a machine that can transport us through the years. It's a question of understanding the very fabric of the universe itself. It's about unraveling the intricate weave of space and time, and understanding how they interact with each other. And that brings us to the theory of relativity, the revolutionary idea put forth by Albert Einstein in the early 20th century. According to this theory, space and time are not independent entities but are interwoven into a single four-dimensional fabric known as spacetime. And this spacetime isn't flat but is curved by the mass and energy within it. So, where does time travel fit into all of this? Well, that's where things get really interesting. But to truly understand time travel, we need to delve into the mind of a genius, Albert Einstein. Albert Einstein, a name synonymous with genius and innovation. Born in Germany in the late 19th century, Einstein's name has become a byword for brilliance. His contributions to the world of science have shaped our understanding of the universe and its laws. Einstein's most famous work, the theory of general relativity, has left a profound impact on the world of physics. Published in 1915, this theory revolutionized our understanding of gravity. Rather than viewing gravity as a force, Einstein proposed that it is a curve in the fabric of spacetime caused by mass and energy. This notion of spacetime, a four-dimensional fabric that underlies the universe, was groundbreaking. But how does this relate to time? In Einstein's universe, time is intertwined with the three dimensions of space, creating a four-dimensional spacetime continuum. This means that gravity doesn't just affect how objects move, but also how time flows. Near a massive object, time slows down. This effect, known as time dilation, has been experimentally confirmed. Einstein's theory also suggested the existence of black holes, regions of spacetime where gravity is so strong that nothing can escape, not even light. Within a black hole, space and time as we know them cease to exist. This concept has inspired countless science fiction stories, but it also has serious scientific implications. Black holes could, theoretically, act as bridges to different points in spacetime, allowing for the possibility of time travel. Einstein's work didn't stop at general relativity. He spent the latter part of his life trying to develop a unified field theory, a single theory that could explain all the forces of nature. While he didn't succeed in his lifetime, his work laid the groundwork for modern theories of quantum gravity. Einstein's theory of relativity opened up a whole new realm of possibilities, including the potential for time travel. His revolutionary ideas continue to inspire scientists and laypeople alike, challenging us to rethink our understanding of the universe and our place within it. Now, let's unravel the mysteries of general relativity. Albert Einstein, the man of the hour, gave us a new way to look at the universe with his theory of general relativity. But what is it exactly? At its core, general relativity is all about gravity. But it's not the kind of gravity that Sir Isaac Newton talked about, an invisible force pulling apples from trees. Instead, Einstein saw gravity as something far more elastic. Imagine, if you will, a giant rubber sheet. This sheet represents the universe, or more accurately, space-time, a four-dimensional fabric that combines space and time into a single entity. Now place a heavy bowling ball on that sheet. The ball sinks, creating a dip or a warp in the sheet. That's what massive objects like planets and stars do to space-time. They cause it to curve, to warp. But how does this relate to gravity? Well, picture rolling a marble across that warped sheet. It doesn't go straight. Instead, it follows the curve created by the bowling ball. This is how we experience gravity. We're not being pulled down by an invisible force. we're following the curves in space-time created by massive objects. So, in essence, the bigger the object, the bigger the warp and the stronger the gravity. That's why you feel much lighter on the moon than on Earth. The moon is smaller, so it warps space-time less, and its gravity is weaker. Now here's where it gets really interesting. Not only does matter warp space-time, but so does energy, and light, as we know, is a form of energy. This means that light, too, follows the curves in space-time. This is why we see light from distant stars bending as it passes close to the sun. It's not being pulled by the sun's gravity, it's merely following the warp in space-time. So, where does time travel fit into all this? Let's find out. Before we continue, please consider subscribing for more intriguing science content. Now let's delve into the tantalizing subject of time travel, a concept that has intrigued human imagination for centuries. According to Einstein's general theory of relativity, time travel isn't just a figment of our imagination or a trope of science fiction, it could be, in theory, a scientific reality. In the realm of general relativity, time isn't a constant entity, it's flexible and can be manipulated. This idea leads us to a phenomenon known as time dilation, which is the difference in the elapsed time measured by two observers due to a relative velocity between them, or to a difference in gravitational potential between their locations. Imagine boarding a spaceship and traveling close to the speed of light. According to Einstein's theory, time would appear to move slower for you compared to someone on Earth. This means that when you return from your space voyage, you could find that while only a few years have passed for you, decades or even centuries have passed on Earth. This is a form of time travel into the future. Fascinating, isn't it? Similarly, a black hole with its immensely strong gravitational pull could theoretically cause time dilation. Near a black hole, time would move slower compared to farther away. So if you were able to hover near a black hole for a while and then return to Earth, you might find that you've traveled into Earth's future. However, it's crucial to remember that these are theoretical concepts. While they're based on well-established scientific theories, we currently lack the technological means to test these ideas. The possibility of time travel opens up a Pandora's box of questions and paradoxes that challenge our understanding of reality. But one thing's for sure. The idea of time travel continues to captivate us, pushing the boundaries of our scientific curiosity. The concept might sound like science fiction, but according to Einstein's theory, it's theoretically possible. Time travel isn't without its paradoxes and problems. As we delve deeper into the realm of time travel, we're confronted with a host of conundrums that challenge our understanding of reality. One such conundrum is the infamous grandfather paradox. Picture this. A time traveler journeys back to a time before they were born, and accidentally prevents their grandparents from meeting. This throws a wrench into the works, as the time traveler should now, theoretically, cease to exist. But if they don't exist, who traveled back in time to disrupt the grandparents' meeting in the first place? It's a riddle that can tie your brain in knots. Another paradox is the bootstrap paradox, named after the phrase, pulling yourself up by your own bootstraps. Imagine a time traveler who brings a book back to an author in the past. The author then publishes this book, which the time traveler will eventually find and bring back in time. The question is, who originally wrote the book? These paradoxes not only boggle the mind but also highlight the complex nature of time travel. They expose potential inconsistencies and contradictions within the concept itself, sparking heated debates among scientists, philosophers, and time travel enthusiasts alike. In addition to paradoxes, there are other challenges associated with time travel. For instance, the energy requirements for a time machine based on our current understanding would be astronomical. This raises questions about the feasibility of time travel from a practical standpoint. Furthermore, there's the issue of the butterfly effect, the theory that small changes in the past can have drastic effects on the future. If a time traveler were to alter even the tiniest detail in the past, it could potentially result in a future unrecognizable to them. Despite these challenges and paradoxes, the allure of time travel is undeniable. It's a concept that has permeated our culture from literature and film to scientific discourse. Each paradox and challenge adds another layer to the enigma of time travel, making it a topic of enduring fascination. Despite the challenges, the concept of time travel continues to captivate our imagination and push the boundaries of our understanding.